Today we're going to be starting a new unit, which is chemical reactions. So just some different examples of chemical reactions, things like nails rusting, dynamite exploding, digestion are all examples of chemical reactions. So some of them are very dramatic, some of them are much more slow, but in each case you have new substances being formed. So a chemical reaction is when a substance changes identity. So we start with our reactants, those are our original materials, and then our products are resulting materials. Every chemical reaction has to satisfy the law of conservation of mass, which states that the total mass of the reactants has to equal the total mass of the products. So in this picture here, we have magnesium ribbon reacting with oxygen gas, forming magnesium oxide, and the total mass of the reactants and the products is going to be the same. So different signs that a chemical reaction may be occurring are things like seeing heat or light, gas bubbles being produced, seeing a precipitate, or color change. And during this unit, I will be showing you some different examples of chemical reactions where you will be able to see these different signs. So when we have a chemical equation, the numbers written in front of our reactants and products are coefficients. If you do not see a coefficient, that means there's a coefficient of 1. In other words, 1 is understood. Our reactants are on the left-hand side of the equation, and our products are written on the right-hand side of the equation. Okay, so we're going to be going over first how to go from a word equation to a chemical equation. So I'll go over some of the symbols and then how you would do this. So when we look at an equation, most pure elements are written as the symbols we find on our periodic table. There are some exceptions, however. The most common exception you'll see are diatomics, and you need to remember these. These are molecules which contain only 2 atoms, and we remember either H-Knopf down or Brinkelhoff or 7 plus 1 friend. So that's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. That is only when they are by themselves. Another exception, which we haven't gone over, is sulfur, which is generally S8 when it's by itself, so it's a ring. And then phosphorus, which when it's by itself is P4. So I expect you to be able to recognize these exceptions and to write them in the correct manner when you see them in a chemical equation. Other symbols you're going to see are if you have 2 things that are being added to or combined with, we use a plus sign. An arrow represents produces, yields, or forms. A double arrow represents reversible reaction. That means a reaction that could go in either direction. If you see an S, L, A, Q, or G, that's telling you something about the state of matter. So S for solid, L for liquid. Something dissolved in water will be represented by AQ, and then G for gas. Sometimes you will also see a down arrow, which just means that you have a solid or a precipitate being formed in your reaction. You probably won't be using that in here, but you may see this online if you're looking at reactions. Other symbols you will see are an up arrow, which represents a gas, which just means the gas is escaping to our atmosphere. A triangle, which represents the reactants are being heated. Sometimes you will see specific information about the reaction conditions written above the arrow. So you might see pressure the reaction is being carried out at, or temperature being written over the arrow. Okay, so let's look at this equation here, and we're going to write this as a formula equation. So I'll show you guys how to get started, and we'll do 2 examples. So let me just go out, and bring up a pen. Okay, so we see we want to look for like things like and or arrows. So those are going to go into our equation. So sodium oxide, we write that just like we've been doing, Na2O. And then we write S below that, and then plus water. This is implying that's a liquid, so I'm going to just put a liquid here. And then we have sodium hydroxide, NaOH, and it tells us it's a solid. And then we would go ahead and balance the equation. We're not going to do that now, but we would balance the equation and then we would be done. Okay, I want to show you another equation. Here we have a little bit more information. When you see things like reacts with, that's going to be become a plus sign in our equation. To produce means we have an arrow there, so that's going to separate our reactants and our products. And then we obviously see an and. So we have potassium chlorate, KClO4. This is a solid. And then reacts with, but this is not another reactant. This is heat. So that means we're going to put a triangle over our arrow. And then to produce means we have an arrow there, and then we have oxygen gas. Oxygen's diatomic, so it'll be O2 with a G sign. And then solid potassium chloride, and then we put an S there. Okay, so I want to look at some of the problems that are in your homework. Okay, so this is your homework, and I want to go through just one of these problems just to show you how to approach these. So when you're doing these, I would focus on words like plus, yields, plus. So remember, plus is going to represent, it's going to separate different reactants in this case, or different products as in this case. Words like yields or produces are going to separate your reactants and products. So things that are on either side of these words are going to be either compounds or elements. So obviously potassium chloride is a compound, and then we have silver nitrate, then potassium nitrate, and silver chloride. So we're going to write these as formulas. So if we see prefixes, remember, those will become our subscripts, and that means we have a covalent compound. If we do not see prefixes, then we have ionic compounds, and we need to use our charges and most likely our list of polyatomics. So we have potassium chloride plus silver nitrate, yields, that's going to be an arrow, potassium nitrate plus silver chloride. Okay, so that's our equations. So guys, I want you to try a couple of these, and then you can check, we'll go over your answers so you could check them.